Hi, I think it started now. Maker's Corner here again. Yeah, this SD card turned into a real mess. Try and go through a few details. Haven't tested everything yet. I think it's up and running now. No, it didn't work so well. It corrupted the SD card. So it was just a mess on the SD card when it comes to files. Let's see. So I'm just adjusting the microphone. Yeah, looks okay. Hope the audio works. And there's a few issues that I ran into which will probably help. One is that there is it needs memory to work when you initialize the SD card library. In my case, it seems to have been eating up a little bit too much on my because I only use an Arduino Uno, so that doesn't got that much memory. Let's see if I can find where did I put that? Yeah, the box sketch is here, and then let's see now. Oh, it could actually work this time. Ah, surprise, surprise. Yeah, XSplit wants me to pay for it now. Well, they have a free version also. I haven't really decided if I'm going to buy it or use the free version. We'll see. Anyway, the memory, it's like there's lots of debates on the internet of how much memory you need, but it a little bit depends on the SD card and what you're doing. But I mean, it's like 400 to 500 bytes is needed free memory to be able to initialize the SD card library. And I think that was thought it was one of my problems in the beginning, at least if I'm running the SD card logic within the context of the thermal experiment box. But anyway, there was a hint. One way to reduce memory use is to move the constant strings so they wouldn't be stored in memory, so that they're stored in flash instead. So then you use this micro here. So you wrap it with this F brackets, and then it'll put all these anything that's a constant string can be then moved into a flash memory. You can't do it with this dynamic concatenation. You can't do it with those types of strings. You can't do it. So you can only do it with these fixed ones. So that was a hint. Otherwise, there's not really that much one can do in terms of memory optimization of code. Also, there's lots of different discussions of different versions of the SD card library. I use the one that you can load using the library manager. This one here. So you include std.h. No, I could take that memory free away. That's actually not needed. Yeah, that's actually, there is one function that I copy-pasted from the net, which was quite useful for tracking memory usage. Let's see if here. I mean, you'll be able to just Google for it, you'll find it. So just Google for function freemem, Arduino freemem, and it's basically looking at the heap space and saying, okay, how much global space do you have available? And then you can like print it out to the serial, like serial.print ln or something, and then you get the values. So that's actually quite good. I haven't actually tested the SD card in the context of the sketch yet, because I ran into other problems. So even when I cleaned up this memory, then it completely messed up the SD card. So I read around and I stumbled around, and then I found out that here, so this works. Now, this SD card module basically does not have a digital voltage level adjustment. So that means as far as I was able to diagnose, the module I have, you can run it on 5 volts, and it has a regulator, and it supplies the SD card with 3.3 volts, but the signaling is 3.3 volts. So that was like, I'm kind of thought that's messing up, because the Arduino basically is working with 5 volt logic. Now, why they built the SD card adapter with the option to run it at 5 volts? You can also run it at 3.3 volts, but I mean, why would they not have the level adapting circuit? I don't know. I suppose it's to save a few pennies. But what I did find after searching a lot was this circuit diagram. It was somebody presumably struggling with the same problem, and basically it's the upper part here that you have to care about. So this is connecting the SD card module, which is 3.3 volt logic, to the Arduino, which is 5 volt logic. And basically the idea is rather simple. So you use pull-up resistor and a diode to so when this goes high on the Arduino side, it's 5 volts, then it doesn't push the 5 volts into the SD card module pin, and according to the text it says that then it can, some SD modules, controllers will get screwed up if you put 5 volts on the pin. And then the pull-up resistor basically pulls it up to 5 volts, but it's still not going to let much current to flow into the pin to mess it up, because it's a 10 kilo ohm resistor. I played around with this circuit, and at least in my use case, to get it to be reliable, and I was measuring with my oscilloscope, is that I put a pull-up resistor on all the pins here, all these 3 pins. Not this one, this goes directly, so this is the output, the SPI output. So okay, basically if I go through, this is an SPI bus, and the SPI bus basically has a module activate pin or chip select pin or signal. So this is just like one to select, and there can be, you can run from other digital pins, you can run to other modules, so you can share the communication cable wires. And then this is the data coming from the Arduino going into the SD card. It's called MOSI, and this is the clock signal that clocks the data, and then this is the data that's coming out of the SD card going into the Arduino, and it doesn't need a level adapting logic, so that'll work fine. Now this part you can ignore. This is just somebody was trying to actually read an SD card to get audio data to push out to this simple audio circuit, but that we don't have to care about. So anyway, so I used the circuit with an adaptation of having pull-up resistors, and that's implemented. Oh wait, I was using, sorry, I was using, I need to switch to here, of course. Anyway, so I'll just do a quick recap since I had the wrong display. Yeah, so anyway, this was the top level part of those. So here you have the SD module, and here you have the Arduino, and then here you have the connections, as I explained. so without actually having the picture. But I mean, the only modification I made was that I added pull-up resistors to these 2 pins here. That seemed to be the best. And this here is implemented, and I was going to show with this one. So that's actually implemented here on this mess. So I have the cables coming from the Arduino and go into this card, and it has that circuitry, and then it goes to the SD card module. And yeah, no, it seems to work pretty good. Could actually show it in action if I switch to here again. And then we take, let's see now, card info, and we serial number. Oh wait, to close that, and then we start, because then it'll get the reset serial number. There you go. So now that came cleanly through, and when it does this process, it doesn't actually end up destroying the card. And I've also done run the data logger script, so that also works. Then I was going to demonstrate. So as I said, I've been using my oscilloscope quite a lot to diagnose these things. So let's see if I move this. Let's see, hope nothing crashes. That's stable, sorry for this. Ooh. Guaranteed to get everybody seasick. Okay. Maybe turn it just a bit more. That'll be good enough. Can't just free that up. Now I'm going to change to another SD card. I hope I don't screw this up. Come out of there. No, can't be difficult. It's so easy to change the SD card. Hope this will work now since I just violently removed it. I usually power down to change the SD card. Come on. So I want to go in there. Huh? There. Gosh. Oh. Now I will just check that this works first, because I was a bit violent. Yeah, that's working. Ah, now you can see the signaling here, and then I'm gonna do a single trigger on SPI, and this is a really good example because I have this is a digital oscilloscope. So what happens is that you have these different types of triggers. So this actually has support to trigger on it has support to trigger on SPI bus traffic. So you can use like one channel for the clock and one channel for the data, and the data can be like incoming or outgoing. And then here you get an approximate view of the data block. And of course, there's many data blocks. I mean, this is not a logic analyzer, so this won't tell you what this data is. It will just show you that there's data. And when I was also had some wiring problems when I built my custom circuit boards. So I was actually looking for this signal, and I didn't find it. So what drove me to use that circuit? The thing is that when you're running, I'll make it simple. You can look it up on, you can Google it if you like. But I mean, if you have a 5-volt logic, levels, then there is a specific range where it's considered 0 and a specific range when it's considered 1. And when you have 3.3 voltage, 3.3 volts, then there's a certain range where it's considered 1 and a certain range where it's then considered 0. And those didn't look that good, those, when I was just trying to analyze the voltage levels. They didn't really look like they were going to work. So that was just based on an oscilloscope picture, thinking that this won't work. So, but anyway, let's let it run again. You can see it's picking up each package. It's wait, maybe I need to actually show what it's doing. So it's actually reading a directory structure. Yeah, it's reading lots of files. It's listing the directories on the SD card, and there's quite a lot of files. Oops. So then you can see that it's, and this is the read wire, so you can call it. So, what the hell is that? I can never remember what they call these names. It's the meso pin output that's being read by the oscilloscope. And I do have a logic analyzer, a hobby logic analyzer, but I think I'll leave that demonstration to another day. But one could connect up the hobby logic analyzer and actually be able to see the data that's being transferred. But in this case, I was just interested to see the signalings were. So again, I think it's a win for digital oscilloscopes. I mean, it's not the best digital oscilloscope, but I mean, it certainly beats trying to figure out if communication buses are working at all, just by using a multimeter or guessing. So anyway, okay, the summary is that when you buy an SD card module from China, I would suggest not buying the module that hasn't got the voltage level compensation chip included. I mean, I know why the Chinese did. That's cheaper, and maybe under. I mean, the wiring diagrams that I've seen online, or actually talk about different modules, so it's actually very difficult to online when one's reading articles to really know exactly what modules they're using. Sometimes they give the type name, but often the modules they give with the direct wiring that I have seen, it does have the voltage leveling circuit, which means that they're let's see here. So this part here is implemented as a chip instead. So it converts 5 volts to 3.3 coming in, and then also 3.3 to 5 volt voltage logic levels, and that's a integrated circuit. However, when one's buying from AliExpress, I don't know. Well, sometimes they give the picture, and then you can actually see that then you need to actually see that the module contains some other chip than something that looks like a voltage regulator. Sorry, people getting seasick again. Bad way to use the camera. No, I think I might be able to actually do this. Am I going to point at that thing? There's nothing, I haven't got anything to point with. I need a pointer. I wonder if my finger will do it. Okay, but anyway, here's the SD card module, and then as you see, there's no there's a discrete circuit, but that's you can pretty much guess that's a voltage regulator, 5 volts to 3.3 volts, and then everything else is passive components, the resistors and capacitors. So what you want to do is you want to buy a module that has a black semiconductor, like a real chip, in addition to the voltage regulator. Then you can I suppose one can pretty much guarantee that then it has a voltage level converter. I didn't buy one of those, but these are really cheap, these without. But then of course, to get it to work reliably, then one needs to actually build this extra circuitry. Now, the odd thing is, it was partially working, so I suppose it's also manufacturing tolerances and stuff, and then it depends on what kind of a SD card you're using. Maybe there are some SD cards that are more tolerant than others being used with 5-volt logic, so it could be that your mileage may vary depending on specifically what type of SD card you're using. But I basically, from an engineering perspective, would like to say that, okay, if one circuitry is 3.3 and the other one is 5 volt, then I should always use logic level converters, or equivalent circuitry like this. I mean, the reason they implemented this one that I showed you with diodes and resistors is that that's what people have in stock at home. Like these diodes and the resistors, and capacitor, they you get with any Arduino building kit or training kit. So the voltage logic level shifters are not usually included in any Arduino like training kit. So you can understand why they made this circuit. I mean, this circuit, based on oscilloscope measurements and looking at the package signaling, it seems to work just fine. So I don't know, I'll just keep it like that. But now I have to move on and see if I still have the memory issue with the experiment box code, because I already use up quite a lot of the memory with the experiment codes. So it could be that I might need to move I still might have the problem of needing to move to an Arduino Mega just to be able to have enough memory. And I'm definitely going to have to do that. I'm going to have to skip the idea of running the networking card, I think, the network module. Because the Ethernet network module will probably take approximately the same amount of memory again. And then I'm definitely out of memory. And I actually don't. The sketch that I have for running the experiments, there really isn't that much one can take away. But anyway, this was both frustrating and fun thing to diagnose, just when I thought that everything was working so nicely. Shouldn't have said it was working, because then one finds out that it's not working at all. But this seems stable. I'm able to read. I've got 3 different SD cards from different generations. I've even got an original size. That size. And then I've got and then this is like total new generation, 32 gig. No, 32. What was this one? I forget. 32. Oh, it's a 32 gigabyte one. So I got the whole, and then I have one middle range. So all of them now work. So I think that the SD, as I said, the SD card library current version exists. It's a hacked version to support that you can open more than one file at a time. The old SD card library could only handle one file at a time. So online, when you read articles, there's many articles about like, oh, make sure you only open one file. But that's not applicable to the current version of the SD card library. But I would assume that if you open more files, then it takes more memory. So yeah, we'll see. Mileage will vary. In this case, I'm only going to open one file. So my next idea is to wrap this up and test the test the experimental code, the experiment code to store. Getting back to this, I wanted to store the every time it takes a measurement set, then it will store it on the SD card, and I think it will probably work. The other odd thing is that this only supports, very important to remember, this only supports old DOS-style naming convention. So it's like 8-character name and a 3-character extension. So I wouldn't, for data logging purposes, I wouldn't try and use the pseudo name, even if it does say it supports the. What's odd is it says it supports both FAT16 and FAT32. If it supports FAT32, then it should understand long file names, but then it basically doesn't. Which is strange, because if FAT32 is long file names. So, but I haven't looked into the details of that. So. I think it actually says, and it actually says that it finds, let's see here. No, this is saying that it found on this SD card, but I think on the other one. Okay. So kind of sharpen. Come on, give me the correct view now. This one. Here where it says volume type is, I think I saw FAT32 there on one of the SD cards. Yeah, could be mistaken. But if it says FAT32, then it should understand long file names. No, actually, I don't think it has anything to do. FAT32 is to do with the size, not with the naming convention. So I think both FAT16 and FAT32 can support long names. So here you can see it's got a lot of pseudo names and concatenating the long name to short. You don't see very much of this nowadays because all operating systems and stuff. But anyway, for data logging purposes, you can always. I'm going to give this 8+3 name. Is there anything else that I found out? So, memory saving with the F function. Yeah. And then this level shifting logic needs to exist if you have one of these SD card modules that hasn't got the level shifting. Or I would recommend it, even if you could probably take a chance that it would work with your specific combination of SD card and microcontroller. Because of course there are microcontrollers that work with 3.3 volts also. But if you're on an Arduino Uno Mega, then it's 5 volt logic. So then I would suggest, no, I think it would be better to have a level shifter. If you have the level shifting circuit, it's not used if you run 3.3 to 3.3 logic. But if you use 5 volts to 3.3, then it's used. So, and basically, I don't think they cost anymore. All right. So anyway, I'll do some more testing and then get back to make another video on if it actually worked with the experiment code. But as I said before, if I'm going to use the Ethernet network module, then I think I will need to start using Arduino Mega. I also have an Arduino Mega coming, which has an embedded Wi-Fi 8266 chip, so that'll be interesting. I don't have to have a separate Wi-Fi chip for it. Yeah, and some other stuff. Okay, I think that's long enough for this video. Same story, if the audio worked, then it's uploaded. If it doesn't, then I give up. And then I have to decide if I'm going to buy XSplit or see what the free version can do. Yeah. There are other studio applications to use. But we'll see. Maybe come back with a video on that also.